All right, as we start Unit 8, our first lesson is about factoring. So m squared plus 6m plus 5 is a quadratic written in standard form, which is ax squared plus bx plus c. So it says list out your factors for a times c. Now a is the implied 1 in front of the m. And c is the 5 on the end. So 1 times 5 equals 5. So if I'm listing all the factors of 5, I know that 1 times 5 is 5. Negative 1 times negative 5 is also 5. So our next question says, which factors of a times c combine to be your b? So the sums of the factors is what you're looking at. So 1 plus 5 is 6. Negative 1 plus negative 5 is negative 6. So if we go back to the equation, we see that the b value is a positive 6. So these are the factors we're going to use. Now, since the a value is 1, we can simply just write our intercept form from here. So we have x and then a factor of positive 1 and x and a factor of positive 5. And that's the equation m squared plus 6m plus 5 factored. So if we look at another one, we have this one, k squared minus 3k minus 54. So again, your implied 1 is at the front. So if we're going to list all the factors of a times c, we have a, there c is negative 54. So a times c equals negative 54. So all the factors of negative 54, we have 1 times negative 54. We have negative 1 times positive 54. 2 times negative 27. Negative 2 times positive 27. 3 times negative 18. Negative 3 times positive 18. And then 6 times negative 9 and negative 6 times 9. Those are all of the factors of 54. So again, we have to find the sums of our factors. So the sum of 1 and negative 54 is negative 53. 1 times negative 1 plus 54 is positive 53. 2 minus 27, or 2 plus negative 27, is negative 25. Negative 2 plus 27 is 25. 3 and negative 18 is negative 15. Negative 3 and 18 is 15. 6 and negative 9 is negative 3. And then negative 6 plus 9 is 3. So now we have to go back to our b value. So our b value is negative 3. There's our negative 3. So the factors we're going to use are 6 and negative 9. And again, because of our a value being 1, you can go ahead and write this in intercept form. So we have x, a positive 6, and x, and a negative 9. And that is our expression factored. So if we look at another one, we have a value is 1, c value is negative 40. So when we multiply those together, we have 1 times negative 40 equals negative 40. So all of the factors of negative 40. So 1 times negative 40 makes negative 40. Negative 1 times positive 40 also makes 40. 2 times negative 20. Negative 2 times 20. 4 times negative 10. Negative 4 times 10. And then 5 and negative 8, or negative 5 and positive 8. So now we find the sums of our factors. So this makes negative 39 positive 39, negative 18, positive 18, negative 6, positive 6, negative 3, and positive 3. So now that we have our sums, we can go back to our equation or our expression, and we see that our b value is a positive 6. So there's our factors. And again, since the a value is 1, we can simply write our intercept form. So we have x, one of the factors is a negative 4, and x, the other factor, is a positive 10. The next one. I'm going to let you guys figure out the next one and us move on to something different. So let's move down to number 5. So the a value on this one, again, is the implied one. Your c value is the 42. So when we multiply a times c, it gives us a positive 42. Now, something you can go ahead and start to notice. When we are looking for that b value, we want it to be positive 13. So we can make a positive 42 by multiplying two negatives, but two negatives don't add up to a positive. So that's our hint that both of these factors are going to be positive. To make a positive 42 that adds to a positive number, both factors have to be positive. So that's going to save us a little bit of time. So we have 1 times 42 makes 42. 2 times 21. 3 times 14, and 6 times 7. So when we look to see which ones have a sum of 13, 43, 23, 17, and there it is, our 13. So again, since the a value is 1, we can simply just jump over to writing our intercept form. So we have x, one of our factors is a positive 6, and x, the other factor, is a positive 7. And the last one we're going to do is number 8. So for this one, your a value is the implied 1. Your c value is a positive 30. 1 times 30 is 30. Now, our b value on this one is a negative 13. So in order to find the factors of two numbers that multiply to a positive but add to a negative, both of your factors have to be negative. Because a negative times a negative is a positive, a negative plus a negative is still negative. So when we list our factors, we want negative 1 and negative 30, negative 2 and negative 15, negative 3 and negative 10, negative 5 and negative 6. When you add your factors to find the sums of your factors, we have negative 31, negative 17, negative 13. There it is. We've already found it, but I'm still going to write the other one just because. So our factors are negative 3 and negative 10 that multiply to make positive 30 and add to make negative 13. So because it's an implied 1 in the front, because a is 1, we can just write our intercept form. So we have x, one factor is negative 3, and x minus 10, because the other factor is negative 10. So what happens when the a value is not 1? That's what we're going to figure out on the back. So these are some examples where a is larger than 1. I do want you guys going through the other 5 problems from the front for practice and then checking your answers later on Canvas, because you need to be practicing in your own time. So with these that have an a value larger than 1, you still start it the same way. A is 6, C is 1, 6 multiplied by 1 is 6. So we know that our two factors are going to multiply to make a positive 6 and add to make a positive 5. Therefore, both factors must be positive. So to make a 6, we can do 1 times 6 and 2 times 3. So when you add your factors, we get 7 and 5. Because your b value is 5, those are the ones we're going to use. Because this does not have an a value of 1, we cannot jump straight into intercept form from here. Instead, we have to figure out what our two binomials will be. So we have your a value. Let's do our whole first term, 6x squared. And then your c value is going to go down here, that plus 1. When we've always done these area models, the box thing, is these other two boxes that combine to make your b. So the numbers that we found out using our factor table that combine to make our b value are 2 and 3. So in this box, we're going to put 2x, and then this box we put 3x. So we're looking for two numbers that multiply to make 6x squared, and then 2x, and then 3x, and then 1. I'm going to start with a 1 because the 1 is easiest. The only way to make a 1 is to do 1 times 1. So how do I make a 1 into a 2x? As I multiply by 2x. How do I make a 1 into a 3? I multiply by 3x. So there's your two binomials. We have 3x plus 1 and 2x plus 1. So we have 3x plus 1 and 2x plus 1. So let's look at another one. So we have this one. The a value is 3. The c value is 12. 3 times 12 is 36. It's a positive 36, and they're going to add to a negative. So both factors will be negative. So we have negative 1 and negative 36, negative 2 and negative 18, negative 3 and negative 12, negative 4 and negative 9. We can go ahead and stop there because I already know what these add up to. So we have 37, negative 20, negative 15, and there's our negative 13 we were after. So again, we set up the box, our area model. Our first term, 3x squared, goes in the first box. Our last term, that positive 12. And then our middle term, we make that middle term up by doing negative 4x and negative 9x. So this one is not as easy as the first one because we don't have a 1 as our c value, but we do have a 3x squared. So we know that 3 and 1 are the only factors of 3. Now, I'm not going to put the 3 on this side because 3 cannot be multiplied by anything to make a negative 4x, not a whole number. So I have to shift it and try the 3 up here. So 3x. Can I turn a 3x into a negative 9x? Absolutely, by multiplying it times a negative 3. So then how do you turn an x into a negative 4x? And that's by doing negative 4 times x. So if you check all of these factors, if I'm looking at the rest of this and I want to make sure that it works, negative 4 times negative 3 is negative 12. So that works. So now we have the information needed to write our binomials. So we have 3x minus 4 at the top and x minus 3 down the left side. Because practice makes perfect, we're going to do another one. So this one has an a value of 4 and a c value of negative 3. 4 times negative 3 is negative 12. Now, to make a negative 12 using multiplication, one of the numbers has to be positive and the other one has to be negative. Because your b value is negative, that lets us know that when we add these two numbers, the negative has to be the larger number, so that when you find those sums, the overall sum is a negative. So if we have 1 times negative 12, that gives us negative 11 as a sum. 2 times negative 6 gives us negative 4 as a sum. There it is. So again, when it comes to the area model, your first term, 4x squared, goes in that first box. Your c value, that last term, goes in that bottom right box. Your factors, put an x with them and put them in the other two boxes. So at this point, I'm looking at that negative 3 as the c value because I know the factors of 3 are 1 and 3. Now, because 3 does not go into 2, I can't put the 3 in the upper right because we cannot multiply 3 by a whole number to make a 2x. So I know that's where the 1 has to go. And the 3 goes here. Now, I also noticed that the negative 6x, that's our negative, and the 2x is positive. So that means that 3 has to be negative. So now look at your multipliers. How do I make a 1 into a 2x? And that's if it's multiplied by 2x. How do I make a negative 3 into a 6x? Negative 6x. And that's if I multiply by 2x. So just to double check, if we look at all of the parts of this, we have 2x times 2x makes 4x. That's perfect. 2x times 1 is 2x. Perfect. Negative 3x times 2 makes negative 6x. And then positive 1 times negative 3 makes negative 3. So that means our binomials are set up correctly because everything in that area model works. So we have 2x plus 1 and 2x minus 3. All right, we're going to do one more and then I'm going to leave the other two for you guys to use to practice. So we're going to do number 14. Actually, let's make it number 15. So number 15 has an a value of 10 and a c value of negative 4. 10 times negative 4 is negative 40. I know that the only way I can multiply two numbers to make a negative is if one of them is positive and the other one's negative. But the sum of those two factors has to be positive. So that means the bigger number, the bigger factor has to be positive. So we have negative 1 and 40 equals 39. We have negative 2 and 20, which equals 18. We don't have to go any further. So when you set up your area model, the box thing, your first term, 10x squared. Your last term, negative 4. Your factors are negative 2x and 20x. So the first thing I notice is that there's a 10 and a 20 right here. I know that 10 times 2 makes 20, so I'm going to put the 2x up here. So then, how do I make 2x into a 20x? And that's if I multiply by 10. So how do I make a 2x into a 10x squared? That's if I multiply it by 5x. So So far, this one didn't work. So this is part of our guess and check. So at this point, we need to figure out something else. And this happens, guys, which is why I wanted to show you guys that. So the second thing I notice is that I can make a 10 by doing 5 times 2. 5 goes into 20, so I'm going to put my 5x up top. And then the 2x on the side. And we're going to see if that works. So 5 times what makes 5x times what makes 20x? A positive 4. And then 2 times what? 2x times what makes negative 2x? That'd be a negative 1. So let's make sure it works before we move on. So we have 5x times 2x is 10x squared. Yes. 5x times 4 is 20x. Yes. 2x times 1 makes 2x times negative 1 makes negative 2x. Still works. And then 4 times negative 1 makes negative 4. So everything works out. Always double check yourselves. So then we have 5x minus 1 at the top and 2x plus 4 down the left side. So those are your two binomials that when multiplied equals the expression given to us.